Hey guys, today we are looking at our first set of notes for Chapter 9, 9.1 Day 1, which is all about right triangle trig. This is going to be kind of these first two sections that we'll cover, really the first two sets of notes for 9.1 will be a recap of just basic trigonometry before we move on to new stuff that we'll be able to do with trig. This should be a review for you from geometry or previous other classes that you might have experienced trig in. Any of you who are doubled up currently in geometry and trigonometry, or in Algebra 2 and geometry, may or may not have seen this yet, so this might be the first time you're introduced to it, but it's still going to be a comprehensive set of notes where I don't assume any prior knowledge. So, hopping into our first box, just introducing or reintroducing ourselves with the 6 trig functions. So in a right triangle, there's going to be all the things that we're dealing with, they're going to be right triangles for right now. We have, if we pick a particular angle to focus on, which we always use this Greek letter theta, it's like a little 0 with a horizontal line through it. If we focus on that angle in particular, in a right triangle, there are 3 sides to that triangle, and we name them based on its relationship with that angle theta. So if from theta you were going on the opposite side of my triangle, we call that the opposite side. Adjacent means next to, so right next to my theta. My opposite and my adjacent are always the 2 legs of my right triangle, meaning the 2 sides that form the 90-degree angle. In a right triangle, we know the hypotenuse is always the longest side. It's always opposite from 90. So that longest side is going to be our hypotenuse. So that's how we name the 3 sides that we'll use for our ratios. Because what our trigonometric ratios are, or just our trig ratios, our trig functions, they are just ratios. They're looking at, from that angle, what are the relationship between the opposite and the hypotenuse? What's that fraction look like? What is the adjacent and the hypotenuse? What's the opposite and the adjacent? It's all just different fractions of these 3 sides. And eventually we'll get kind of more acquainted with which ones we want to use. But for today, we're just going to be familiarizing ourselves with taking a triangle that we know information about and just evaluating those 6 trig functions. So, the 3 that you are probably familiar with already are sine, cosine, and tangent. And again, these are pronounced, these are actually written sine, cosine, and tangent are the names of them. These are the abbreviations, sin, just SIN for sine, COS for cosine, and then TAN for tangent. Those are the 3 that you're probably familiar with. You definitely cover that in geometry. You may or may not have seen the other 3 that we'll cover, but the sine of a right triangle is the relationship between the opposite and the hypotenuse, which I can abbreviate. We just use the first letter, O, A, and H. Opposite, O, A, adjacent, H, hypotenuse. So my first 3 big functions, sine is just the fraction opposite over hypotenuse. Cosine is the adjacent over the hypotenuse. And then tangent is the opposite over the adjacent. Those are my most important 3 trig functions. You've definitely covered this in geometry. You've definitely seen this before. If you've done trig, those are the big 3. And we kind of have a mnemonic device to help us remember the order of them. You've probably heard the phrase SOHCAHTOA. Oops, if I can spell it correctly. SOHCAHTOA just helps us remember the relationships. And actually, I actually prefer writing it a little bit differently. I still say SOHCAHTOA out loud, but just to help us remember where the relationship is for which one's the top of my fraction, which one's the bottom. I wrote it this way: SOHCAHTOA with O over H, A over H, and O over A for my original 3 functions. So if I was looking at, I had side lengths, I could just put those in there. It's just kind of fill in the blank once we've identified which one's my opposite, my adjacent, and my hypotenuse. So those are my original 3 trig functions: sine, cosine, and tangent. My other ones, these are called the inverse functions because they're just reciprocals of the other connected functions. So this is called CSC is cosecant, SEC is secant, and then COT is cotangent. So cosecant, secant, cotangent. And the way that they're paired, like the way that the relationships are set up, is that my cosecant, this is the same thing as 1 over the sine of that same theta. Secant is 1 over cosine, and then cotangent is 1 over tan. So that's why they're called the inverse, or sometimes they're also called the reciprocal functions. So we've got my regular trig functions and then my reciprocal trig functions, because they're literally just the reciprocal of my original 3. So if cosecant is 1 over sine, which is just the flipped over version of sine, it becomes hypotenuse over opposite instead of opposite over hypotenuse. Secant is the reciprocal of cosine, which means hypotenuse over adjacent. And then cotangent is 1 over tangent, which means this is adjacent over opposite instead of opposite over adjacent. So you can just see we're just flipping the fractions over. So, I mean, there's not really, we don't usually use one of the shortcuts for it, but if you want to call it something, cosecant is hypotenuse over opposite, secant is hypotenuse over adjacent, and then cotangent is adjacent over the opposite. So not quite as elegant as SOHCAHTOA, but CHO-SHA-COW, sure, if that helps you remember the reciprocal functions, that's fine. The way I do this, and we'll get into an example now that we've kind of established basic info, I usually just start with the big 3, sine, cosine, tangent, and then just flip them over for my 3 reciprocal functions for cosecant, secant, and cotangent. All right, so getting into box 2. Box 2 is just asking us to evaluate my 6 trig functions given this right triangle. So before we can get into actually evaluating them, we need to establish which side is the opposite, which side is the adjacent, and which one is the hypotenuse. If you can't do that, you can't do anything any of the rest of it. So again, theta is up here now on my top left side. The opposite always is across my triangle. So I have to go through my triangle to get to the opposite side. So in this case, my opposite would be 3. That means this is my adjacent, positive 4. And of course, my hypotenuse is my longest side, is positive 5. So 3, 4, 5, which, if any of you guys remember that from back in geometry, this is a Pythagorean triple. It's one of those special right triangles that always work out in that pattern. That'll be important for us moving forward. We'll talk a little bit more about those special right triangles and Pythagorean triples a little bit in day 2 of 9.1, but especially moving forward, some of those special right triangles. All right, so now that I know what is opposite, which one's adjacent, which one's hypotenuse, I can just go in here and start setting up my fractions. So just so I don't have to keep scrolling back and forth, we'll just remind ourselves and say opposite is 3, adjacent is 4, and then our hypotenuse was 5. So sine is opposite over hypotenuse, so 3 over 5. Cosine is adjacent over hypotenuse, so 4 over 5. Tangent is opposite over adjacent, so 3 over 4. And now my reciprocal functions, whether you want to remember it as hypotenuse over opposite, hypotenuse over adjacent, and hypotenuse or adjacent over opposite, you can do it that way. But again, they're just reciprocals, so now that I already have these 3 fractions set up and everything, I can just flip them over. My cosecant is 5 over 3, secant is 5 over 4, cotan is 4 over 3, because I'm just flipping over those original 3 fractions. And I'm done. That's all I have to do. Where it will get more difficult is where we're not necessarily given all of the information in my triangle. I don't have all 3 of my sides in my right triangle. So I'm going to need to do a little bit of work first to make sure I have all 3 sides, and then I can go ahead and evaluate my trig functions. So with box 3, we've got this right triangle set up. Theta is down in my bottom right corner, and I have my 2 legs. I know 5 is my opposite side, 12 is my adjacent. I don't know what the hypotenuse is, though. I need to figure out what this h is. So what I know is that this is a right triangle, so we should know Pythagorean theorem, right? That still applies even though we're not talking about Pythagorean theorem. You haven't talked about it maybe since geometry or your pre-algebra back in middle school, but Pythagorean theorem still applies. Pythagorean theorem, remember, tells us the relationship between the three sides of a right triangle. If I square the two legs and add them together, it should add up to the square of the hypotenuse. So usually written a squared plus b squared equals c squared, where a and b are my two legs, and c is the hypotenuse. So if I go ahead and plug in stuff that I know, my opposite is 5, so 5 squared plus 12 squared is going to give me h squared, if we want to say h. So that's 25 plus 144 equals h squared. 25 plus 144 is 169. So if I take the square root of both sides, I end up with technically plus or minus 13, but we know that a side length can't be negative, so that tells me my my hypotenuse has to be positive 13. So a little bit of work, but now I have all three sides, and it's just like we did for box 2. I'm going to go ahead and I can scroll out far enough that I can see everything. So again, SOHCAHTOA. So let's do that in green. So sine is opposite over hypotenuse, so 5 over 13. Cosine is adjacent over hypotenuse, so 12 over 13. And then tangent is opposite over adjacent, so 5 over 12. And then my three reciprocal functions are just the reciprocals of those three that we just did. So 13 over 5, 13 over 12, and 12 over 5. Awesome. All right, last but not least, box 4. So box 4 is even more complicated because I'm not even given a triangle to start with. It's not giving me a picture. I don't know where the theta is. I don't know opposite, adjacent, hypotenuse, any of those things. I'm just told we're dealing with a right triangle. And theta is an acute angle, meaning it's a right triangle like we're used to seeing. Those two things just set up saying it's normal, what we've been doing. And they tell us that sine of that angle, sine of theta, is 5 over 6. And they want us to evaluate the other 5 functions. So when we're given this, I always want to start by drawing a picture. So I'm going to go ahead and grab my pen. I think I can actually... I don't think it's going to be a right triangle. That's all right. I'll just sketch it freehand. So if I just set up a right triangle, it doesn't matter where you put the theta or what kind of orientation your right triangle is in, as long as you decide where the theta, like once you decide where the theta is, as long as everything else goes along with that, then you're fine. So the only other information that we're given, actually really the only information we're given, is that the sine of that theta is 5 over 6. So what we need to know, or we need to realize, sine is always opposite over hypotenuse. Remember, in SOHCAHTOA, the sine ratio is the opposite side of that triangle over the hypotenuse side of that triangle. So in this right triangle, from theta, my opposite side is here, my hypotenuse would be here. So opposite is 5, my hypotenuse is 6. So those are my two sides of my right triangle. So now that I've established that, this looks pretty similar to what we just did in box 3. I have to go through and use Pythagorean theorem to solve for that third side. I know one of my legs is 5. I know my hypotenuse is 6. So I'll have to figure out what that third side is. So if we do a squared plus 5 squared equals 6 squared, right? Because this would be my unknown side, this adjacent side. So a squared plus 25 equals 36. We'll subtract 25 on both sides. A squared is 11. So when I take the square root of both sides, I get square root of 11. Not the nicest, not the prettiest for sure, but it's at least a number. It's something. Okay, so, ooh, I left a lot of space for myself to do that stuff. All right, so they want us to solve the other 5 functions. Obviously, we already know what sine is, so we don't need to reiterate what that is. It's already 5/6. But just to remind ourselves, the opposite is 5, the adjacent is the square root of 11, and then the hypotenuse is 6. So cosine is adjacent over hypotenuse, and then my tangent is opposite over adjacent. And now this is the first issue we've had like this. We have a radical in my denominator, and we know we're not allowed to have that. We have to rationalize it. So in order to rationalize that, we did a couple chapters ago. We have to multiply by the same radical to rationalize. So this ends up being 5 square root of 11 over 11, because those two radicals end up being squared and they cancel out. So because technically square root of 11 times square root of 11 is square root of 101, which, no, you're good. So 5 root 11 over 11 would be your final acceptable answer for tangent. Now my other ones, cosecant, secant, and cotangent are just my reciprocals. So if sine was 5 over 6, cosecant is 6 over 5. Secant is 6 over square root of 11. And shoot, it's going to happen again. We have to multiply by square root of 11 on top and bottom to rationalize. So we end up with 6 root 11 over 11. And then last but not least, cotangent. Be smart here. We got to flip it over, but I don't want to flip over this big nasty one that's already been rationalized. I can go back to what was originally in blue. The opposite over the adjacent is my original tangent, 5 over square root of 11. So if I do adjacent over adjacent over opposite, I end up with square root of 11 over 5, which does not need to be rationalized because my denominator is just a whole number. All right, so that is all for day 1 for 9.1. Your homework is down there at the bottom of the page. It's page 466, 5 through 20 all. As always, if you guys have any questions, concerns, thoughts, ideas, hopes, or dreams, make sure you guys are reaching out and letting me know. Otherwise, have a fantastic day. We'll see you soon.